Hey everybody, in today's lesson we're going to talk about abstract classes in Java. Abstract classes, they are a generic class. What that means is they are a super class that helps define more specific classes. I think the best way to explain it is show an example. For example, we think of a vehicle. You have different types of vehicles, cars, trucks, buses. They're all vehicles. The concept vehicle is abstract. You tend to either purchase and drive a car or a truck or a bus or a motorcycle, something like that. That's the specific type of vehicle that you drive, but they are all vehicles, right? So we think of the term vehicle as a more abstract concept. So what are some features of abstract classes in Java? First of all, an abstract class cannot be instantiated. You cannot make objects of an abstract class. However, now that actually might sound similar to an interface. As you recall, when we use an interface in Java, we also cannot instantiate or make objects of interfaces. But there's a difference with abstract classes. With abstract classes, they do contain a constructor, which you might think to yourself, well, why do they contain a constructor if you cannot make objects of the abstract class? Well, you'll see in examples later why it's possible or why it's necessary to have a constructor, and that's primarily because the subclasses can call the constructor of the superclass the abstract class, and that happens a lot. So the abstract class can have a constructor, even though you don't actually make objects of the abstract class. Next, similar to interfaces, abstract classes are similar to interfaces, except the abstract class can contain non-abstract methods. If you recall from our talk about interfaces, they are full of methods that are all abstract. They all have a method header but no implementation. That makes them abstract. But in abstract classes, you can have non-abstract methods, methods that are fully implemented. We'll see that in our example in a second. Also, abstract classes can contain variables. We don't typically call them instance variables, however, because we don't make instances or objects of abstract classes. So we'll just call them variables. Okay, so abstract classes can have variables. Lastly, the abstract class should implement all the methods that are common to all the subclasses. So this is what you're going to be doing in your next assignment. You're going to have a group of subclasses that are all similar and have some similar characteristics. And so you're going to take all of those methods that are similar to all the classes and move them into the abstract class because the abstract class should implement all the methods that are common to all its subclasses. All right, another example. Let's think about pets. Many of us have pets at home. You might have a dog, a cat, maybe even a pig, pet pig. Okay, maybe not, but here we go. Here we have a hierarchy. The idea or concept of a pet can be considered an abstract concept, okay? If you have a pet, you have a specific kind of pet. You have a dog, you have a cat, you have a pig, you have a donkey, I don't know. You have a parakeet, you have a goldfish. These are all pets, okay? But again, the concept of a pet is abstract. And so in our example here, we'll declare the pet abstract class and then 3 subclasses that all inherit from it, and they can be of different types. So here's our example of our abstract pet class. So at the top, we see that it's declared public abstract class pet. Okay, and so that a keyword abstract defines it as an abstract class. Like we talked about earlier, a abstract class can have variables. So here we have a variable called name. That concept being that all pets have a name, okay, because they're a member of the family and we give them a name. So every pet has a name. We learned earlier that abstract classes also have a constructor, even though you don't actually make objects of the abstract class. So here we have a constructor. When you make a new pet, you give it a name, and you pass in an argument, pet name, which then is assigned to the variable up above, name. And so this constructor works for this abstract class. Next, we have an accessor method, our getter, getName, which simply returns our variable, the name. We also have a toString method, which returns the name from above, the variable, but it also concatenates a string that combines the name with the result or return value of the method's speak. So for example, a dog says woof woof, a cat says meow, a pig says oink. We see that when we return the toString, we want to give its name plus also the kind of noise the animal or pet makes when it speaks. So that leads us to that last final method called speak. But we see down here that this is an abstract method. It has a header but no implementation. This is similar to the interfaces that we've seen before. And so we learned earlier that an abstract class can have both regular methods and also abstract methods, unlike an interface, which can only have abstract methods. What we do is, again, earlier, we put into the abstract class all those methods that would be common to all subclasses of the abstract class. For example, you would want to be able to get the name of any pet you have. You would want to be able to create a toString method, a string for any subclass, pet class that you have. And so these are common to all pets. So we'll put them in the abstract class. However, what an animal says, again, woof or meow or oink, these are all unique to each subclass. So we will make that an abstract method and then define it or implement it down in the subclass. Let's take a look at that. Here's one of the subclasses that extends pet. We simply state it as a public class dog. It extends pet, and it has a constructor like all classes should. And it, however, it also takes an argument of a name. But what it does when that constructor is called is simply call the superclass, which would be the abstract class. It would call that abstract class's constructor. Again, that's why abstract classes have constructors, is because they're going to be called from in the subclass. So we see that happening here. And then it also implements that abstract that abstract method that comes from the abstract pet class. And so while speak was declared as a method up in the abstract pet class, here it's actually implemented. Okay? And so when a specific pet, a dog, speaks, it says arf or woof or something. You get the idea. Okay, so I'm not going to show you the example for the cat or the pig because they would be quite similar. One thing to note is that you don't need to implement the classes that were, or methods that were fully implemented back in the pet abstract class. For example, the getName, going back here, but the getName and the toString, you see those are not being implemented or even included in the dog class. They don't need to be, because you can simply use the getName and toString methods of the super abstract class. They will work just fine for the dog. Next, let's talk about some of the rules that apply to abstract classes and methods. First of all, if a class contains abstract methods, it must be declared an abstract class. Okay, so that's important to remember. If a subclass of an abstract class does not implement all the abstract methods of the superclass, it too becomes an abstract class. So for example, in our dog class that we just looked at, if it had not implemented the speak method, which was abstract in the pet class, then the dog class would become abstract as well. Okay? So you must implement those abstract methods in the subclasses to keep them from being abstract. All right. So for the last few weeks, we've been working on our 11s game. It's a solitaire card game, And we learned to play that, and we implemented that game. What we're going to do next in our next assignment is you're going to implement or create 2 more solitaire card games. One of them is called 13s. It is very similar to the game 11s, except it has 1 more card on the board. It has 10 cards on the board. The cards ace through queen correspond to the values 1 through 12, and they are removed in pairs that equal the number 13. The king, however, corresponds to the value 13 in and of itself, so it can be removed singly. And the chances of winning in this game are 1 out of 2. In other words, it's a lot easier to win than the game 11s. It's a lot easier to make those pairs. Okay. In addition to the game 13s, we're also going to create a game called 10s. 10s is a solitaire card game that has 13 cards on the board. The cards ace through 9 correspond to their expected point values of 1 through 9. And those cards can be removed in pairs that equal the value 10. However, you can also in this game remove 10s, jacks, queens, and kings if you have 4 of a kind, meaning a quartet of 10s or a quartet of jacks or kings or queens. For example, if you had the king of spades, the king of hearts, the king of diamonds, and the king of clubs all up, face up on the board, you could remove them all together. The chances of winning in this game, however, a little more difficult, are 1 out of 8. So let's take a look real quick at what's this called, a graphic or something that would represent the hierarchy of what we're going to be doing in this assignment. What you're going to have to do is think to yourself, what methods, and actually even variables, would be common to all 3 of these games, whether we're playing 11s or 13s or 10s. There are probably a bunch of methods that would be common to all 3 of these games. Doesn't matter if you're playing 11s or 13s or 10s, the methods will apply to all 3 and work just great for all 3. Okay? So what you're going to be doing is figuring that out and then taking those methods from the 11s game that you already have a working version of, and you're going to move those into your abstract board class. So a board is an abstract concept. It's a game board for playing a game, some kind of solitaire card game. But the specific games here, 11s, 13s, and 10s, are all extending that abstract class. And so anything that's common to these 3 games would be moved into the board abstract class, but anything that's unique, for example, to 11s or 13s, would only be implemented in the 11s, 13s, or 10s board class. Okay, so that's where we're going. Hopefully this all makes sense to you. You can start to see the concepts here of how you would use an abstract class. Again, we're trying to aim for code reuse, where you don't want to have to write all the code, for example, of an 11s or 13s or 10s game and repeat or copy all of that code in each of these other subclasses, when you can actually write all of that shared code in one place, an abstract class, and then share it with your subclasses. Alrighty, so hopefully that makes sense. I'm going to be doing another video that's going to show you a bit more details about the assignment. Thanks.